Welcome to the lecture on pure endowment and life annuities. So, we will be talking about endowment, pure endowment cases and also the types of life annuities. And we have discussed in the last class, last lecture in fact, about the mortality table, and we also had introduction to the concepts of mathematical terms related to insurances. So, coming to the definitions of or the description of about the pure endowment cases or the life annuity cases, we must be conversant with certain terms, commutation terms, and these terms these values are given in the mortality table itself. If you refer to the mortality table, which is basically which is this one. So, here we know that in this case you have this as the age, then you have this as the number of persons who are live at certain age, then this is the table Lx is that, and then Dx is telling about the deaths which are occurring. So, based on that and depending upon the death you can calculate the probability of that death. So, that is Qx. Then you have all these other terms like Dx, Nx, Cx and Mx. These are the commutation terms, and we must know that how they are computed. So, the first term is Dx. So, this Dx is shown here. Now, this is basically the present value of suppose $1 for each person at age x. So, this is present value of $1 for each person alive at age x. So, for each person alive at age x, what will be the present value? So, we know that for finding the present value, you have to multiply with the present value factor, and if you have something in the future and if you have to find its present value, then you will have to multiply with the factor 1 by 1 plus r raised to the power n. So, the n will be the time periods where r is the interest. So, based on that we calculate this Dx. So, Dx is the present value of $1 for each person alive at age x, and so it will be calculated. So, it will be calculated for each age group by multiplying this is present value. So, whatever will be the present value for $1 by number of living people in that group. So, what you do is the number of living people in that group, that is Lx, and that will be multiplied by the present value of $1. So, you can find, so you can define this Dx as the Lx into Vx. So, that is your present value of $1 for certain age. So, that will be Vx. So, you can also write it as Lx, and it will be nothing but 1 plus r raised to the power x. So, basically if you can if we refer to that table, you can see that this table, and so you require to have a certain value of r, and our table, which is this one, this is based on 5% interest rate. So, for 5% interest rate you can calculate the value of Dx. So, for 0% certainly we know that it will be 1 lakh into 1 by 1 plus r raised to power 0. So, it is same. So, it will be 1 itself. So, it is 1 lakh, but otherwise you can calculate it. For example, if you are if you are going to calculate this dx for a person at age 40. So, dx for a person of age 40. So, for age 40, if you look at, you will have to refer to the table and you have to find the LX, that is number of persons who are alive at 40 age, and that is given as 94,926. So, it will be dx will be LX into Vx. So, LX is nothing but 94,926, and then it will be multiplied with the factor 1 by 1 plus r, that is r is 0.5%. So, 1 by 1 plus 0.05. So, 1 by 1.05 raised to the power 40. So, that way you have 1 by 1.05 raised to the power 40. So, this way you will get the value of 13,483 and 0.83. So, if you look at the table, by looking at the table in this case of 40, if you go to the dx value, it will be 13,483.83. That is what you can find these values from the table. Next term which will be useful will be nx. So, this value nx, it is the present value of annuity of payments for all persons. Living at each age group. So, basically we are taking the summation. So, we are going to calculate that for the each age group from x to end of table. So, basically we are going to calculate from x to the end of the table. So, and we know that the table is ending at the age of 100. So, we are going to go up to age 100. So, basically it is nothing but the summation of the d, which as we have computed, it will be calculated as the sum of those values. So, nx will be basically dx plus dx plus 1, like that it will go up to 100. So, it is written as something like k equal to x plus 100, and you are going to find the dk. So, this is how you are going to calculate these nx values. Like you have for every person of in of the 70 years, you calculated annuity of each person is, suppose it is computed as 500 per year. Now, in that case what you do is we are going back to that age group, and we are calculating we are calculating this annuity by multiplying with the N70, and N70 can be computed from the table. So, if you calculate from the table, so if you refer to the table, that will be your so what you do is basically you are so this is your N, and it will be calculated. So, you have to have the value of all this summed up. So, for 70, if you go to the next one, now for 70 it is coming out to be something like 21,462.35. So, it is nothing but the summation of all these dx after from here from 70 onwards. So, if you sum them, it will be coming as 21,427. We can even get the things clarified from this table also, and as you see that it will be 25.42 plus 12.76 is coming out to be 38.18. So 38.18 plus 18.32 it will be coming as 56.60. So basically it is a summation from any value dx and it will go till age 100. So it will be giving you the sum of all those values. Then the next term, next commutation term is finding the Cx. Now what is Cx in that case? So Cx will be basically the present value of $1. So it will be present value of $1. So this is for $1 of payment. To people or beneficiary who die at age X. So what you do is that you multiply that the number of people basically who will die at age X, suppose, and that will be multiplied with the present value of $1 at the time x plus 1. So what you do is you calculate the Cx as the number of people who are dying at age X, and then it will be multiplied with the Vx plus 1. So basically this is the present value of $1. So you are going to give after that you are going to give the the payment. So you have to multiply that with the factor. So it is Cx will be computed as dx into v raised to the power x plus 1. So if you can find, so if you look at the tables, this Cx table, it will be talking about these values. So your dx, that is number of deaths, and then that will be multiplied with these values. So if you look at the dx, it will be here, and you can for 0 it is certainly so it is coming as 1200 that way. Then what happens for the this way you are going to compute these values. So 1260 multiplied by 1/1.05, so that gives you 1200, but after that your other values are slowly changing. So basically this value can be computed at any point. Then one of the other term which is used also, that is mx, and this mx is basically the summation of all the Cx. So as we see that the Cx is present value of for $1 of a payment of people who die at age X. So in that case you are talking about the person who are dying, and then you are multiplying that with that factor. Now you are summing them all from there up to age 100. So that way you will be finding the value of nx. So so if you can write, it will be, it represents present value of $1 payment for all people who eventually die but are still alive at age X. So what you do is just like nx, here also you are going from age X to age 0 in fact. So what you do is mx will be Cx plus Cx plus 1. So like that it will go up to 100. So basically you are finding equal to x plus 100, and then you are finding the Ck. So that way you find these mx terms. So you can, so all these, so if you look at, so what we mean to say that if you have this table, you are knowing these commutation terms like dx, nx, cx and mx, and we have to refer these values when we discuss about the endowment or the life annuity values. So now we will come to the value of the definition of the endowment. Now what is endowment? So endowment, a pure endowment is a single payment received at a certain future time by a person who has to be alive at that time, and since the payment is received at a future time, so certainly you will have to multiply with the factor to find the its present value. So here it is equivalent to the discounted value of the payment. So that way we find this pure in pure endowment cases. Now suppose if the NEX is the contribution. So for suppose for the pure endowment cases, so for pure endowment, suppose if the NEX, if it is the contribution of $1 for n years by each person age x. So in that case the total premium will be multiplying this contribution by the number of people. So so if you look at the total premium will be multiplied, so you will be found by multiplying the this contribution, the contribution with number of persons which are alive. So multiplying the contribution with number of persons alive. So in that case your number of alive persons alive at any age is, we know that is the table under the column LX. So you are to find so what you do is that if you what you should do is that if you are discounting it to age x in that case, and if you are receiving at x plus n, so in that case what you do is you get Lx into NEX. So because you are going to for n years, so Lx into NEX, so it will be basically Lx plus n and divided by with the factor 1 plus r raised to the power n. So this way you will be finding these values after discounting. So if you try to find the value of NEX, so NEX will be basically Lx plus n divided by 1 plus r raised to the power n, and then it will be divided by Lx. Now this can be further written. So this 1 plus r raised to the power n, so you can write that Lx plus n and into 1 by 1 plus r raised to the power n, and then it will be divided by Lx. So this factor, as you know, 1 by 1 plus r raised to the power n, it is v raised to the power n, that is the factor. So you can write Lx plus n into Vn divided by Lx. So this is for a hypothetical value of $1. Now if if the actual payment if you have to do calculation for the actual payment P, in that case you have to multiply this with the value P. So in that case for so if you try to calculate for the actual payment P. So, for actual payment P, you have to multiply that with that payment. So, it will be NEX, it will be P times. So, you have to multiply that with P, and then you have LX plus N by LX, and then you are multiplying that with VN. So, this is how your NEX, which is the contribution of for the n years by each person of age X, this can be computed. This value can further be simplified. So, if you look at the expression, that is NEX, so you can you write it as P into LX plus N divided by LX into V raised to the power N. Now, that can further be simplified, and NEX you can if you write you can write it as LX plus N into Vn into Vx divided by Lx into Vx. So, we are not taking at this time as P. Now, you can further simplify this as these values. Now, so this will be like Lx plus N, and it will be Vx plus N, and then it in the bottom it will be Lx into Vx. So, you can write now this is basically Lx into Vx. It becomes if you recall, that becomes equal to dx. So, you can write it as dx plus n and divided by dx. So, for the payment P, you can write that NEX for the actual payment P will be P into dx plus n divided by dx. So, at any point of time, if you have to calculate this NEX, it will be P times you have to refer to the table d x plus n divided by dx, and you can find the value of NEX. So, if you have you can refer to you can solve them problems based on such data if you are asked. Suppose a person, so suppose one example is there that for a 55 years age old person, now he wants to receive a pure endowment. So, wants to receive pure endowment of $50,000, and his so this is 50,000. Now, he is 55 years age, and when he is after retiring at, so when retiring at age 65. So, in that case, how to find how much he has to pay now. So, how much he should pay now. So, in that case, what is there, that you are putting some amount, and then he will be getting maybe after 10 years. So, your n is 10, x is 55. So, x plus n is 65, and in that case if you have to calculate, you will calculate NEX as P times. So, it will be P is 50,000. So, that is what he wants to receive, and then it will be d of so you have to calculate this d of 65 by d of 55. So, directly you can use this table, and if you look at the table, so d65, so d65 will be here. So, d65 is coming out to be 3234.37. So, that is what it is, 3234.37, and d55 will be here. So, this will be 6036.50. So, if you take 50,000 into 324.37 divided by 6036.50. So, that will give you this value. So, it will be 50,000 divided by 3 to 34.37 divided by 6036.50. So, it is coming out as 26,790. So, like that you can calculate these values. Now, the next thing which we wish to get introduced will be the life annuities. Now, this we are going to discuss something about the single life annuities, and the single life annuities are for a single living person and they cease when the person dies. So, they are normally of two types, one is whole life annuities and another is temporary life annuities. So, the whole life annuities as we know, as the name indicates, it is paid to the annuitant as long as he or she lives. It is under three categories: ordinary, due and deferred. Similarly, you have temporary annuities, and these temporary annuities as contrary to the whole life annuities, where it is for the whole life, it will be for a certain contracted period of time, given that he is alive throughout that period, and again that also is classified into ordinary and the due and the deferred. So, we will have some introduction about these, and we will also try to find the value of the endowments in such cases. So, coming to the whole life annuities, if you come to the whole life annuities. So, as we know that in whole life annuities you are going to, so the person is going to pay that annuitant is going to be paid as long as he is living, and in that we are having the different different types of these whole life annuities, and among them you have ordinary whole life annuities. So, if you go to the whole life annuities, so here you have ordinary whole life annuities. So, in this case basically receipt of payment will be at the end of every year, and there will be series of individual pure endowments. So, in this case, if suppose A is the if A is the present value of $1 each year, for each person, or 1 year for each person in age group X. So, the collective endowment in that case will be 1 EX plus 2 EX plus something like, so it will go up to 100 E. So, that way it will be the you can find these collective endowment values, and in this case if you do the simplification and if you do the computation, so you can write further EX as, so it will be dx by dx plus 1 by dx, so it will be further dx plus 2 by dx, like that it will go. So, basically what is happening is you calculate this as nx plus 1 by dx, because in the numerator you have dx plus 1 plus dx plus 2 up to 100. So, its sum will be nx as we have found out, and that will be nx plus 1 by dx. So, basically by using this formula you can find the the endowment values in such cases. So, this is the case of ordinary whole life annuities. Now, if you have there is example of there is another type of this, that is the whole life annuity due. Now, what this annuity due means, that in this case the first payment will be made at the time of purchase itself. So that is why it is known as the annuity due. So you are making one payment while purchasing itself. So in this case what happens that you are making, so that is why we define it as 1 plus AX. So because we are making one payment at the time of purchase itself, and this is for the whole life annuity due, and this is for the ordinary whole life annuity, and in that case you are adding 1. So basically what you do is in this case, if you further simplify, you will have a double dot x, it will be 1 plus nx plus 1 by dx. So basically it will be dx plus nx plus 1 divided by dx. So basically you are adding all of them, and you can further find. So if you do the simplifications basically for payment P. So if you have for payment P, you can calculate the a double dot x, it is as nx upon dx. So basically you are showing the summing. So you are, once you are adding, as you know that nx is the summation of dx. So every time you, so once you do sum this will be nx. So basically in this case it will be, so while in that case it is nx plus 1 by dx, it will be here in the case nx by dx. So that is how you calculate this whole life annuity due. Similarly you can have the annuity deferred to certain certain time period n. So that is the case of annuity deferred whole life annuity. So in that case you are deferring the payment. So this is deferred whole life annuity. So in this case basically you are first payment is deferred to by the period n. So first payment is deferred to a period n, that is beyond 1 year after the purchase date. So in this case purchase is occurring at age x. Now in this case your first payment will be deferred by certain time. So it will be x plus n, it will be going like in that case x plus 1 plus n it will be, otherwise it is after the first year. So then also it is n years of deferment. So it will be x plus 1 plus n. So in this case we define this value as nax, that is deferred by period n, and in that case it becomes n x plus 1 plus n divided by dx. So in normal ordinary whole life it is n x plus 1 by dx, then you have the annuity due, you have nx by dx, and if you are doing the deferring to a period of n, then it becomes nx plus 1 plus n divided by dx. So that is how these values are computed. So this is about the whole life annuity. Then we have temporary life annuities. Now as you in this case it is for as the whole life annuity, it is the payment is made for the whole life. Now in this case it is not for the whole life. So this is temporary life annuities. So it is only paid for a certain contracted period of time. So paid only for a certain contracted period of time, and there also you have a condition, provided annuitant is alive throughout that period. So in this case also when the person will die, the payments will cease. Now for the ordinary temporary life annuity, now in this case as we know, this is basically in this case you know the if the term of annuity is n and the present value of the temporary life annuity is a you know x n, and which is shown by this. So, this is for the temporary life annuity, ordinary temporary life annuity. So, it will be basically the difference between the whole life annuity and the deferred whole life annuity. So, it will be AX minus NAX. So, as we know that AX is coming out to be NX plus 1 by dx, and then for the deferred annuity you have NX plus 1 plus N by dx. So, basically it becomes equal to NX plus 1 minus NX plus 1 plus N divided by dx. So, this is how you are computing for the ordinary temporary life annuity, and if it is for payment P, then you are going to certainly multiply you know P here. So, it will be P into Nx plus 1 minus Nx plus 1 plus N divided by dx. So, this will be for payment P. So, similarly you have also the cases like I mean different types of temporary life annuities also. You have the deferred also temporary life annuities which has the different expressions, and you can study and have you know the idea about these annuities, like if you find the you know foreborn temporary life annuities, it will be you know Nx minus Nx plus 1 divided by dx plus 1. Similarly, if you have the you know deferred temporary life annuity, it will be Nx plus k. So, if the k is that periods, Nx plus k minus Nx plus k plus n divided by dx. So, this way you calculate this foreborn type of temporary life annuity and the deferred temporary life annuity, and you can calculate all these values by referring to the tables. So, this way you can you know have the idea and do more practice to have you know the control over these things. Thank you very much.